So in our last class, we calculated what node N3 contributes to the overall error. And here it says 0.52. We also did same for node N4, and then it contributes 0.044 to the overall error. And lastly, we also did for node N5, and then node N5 contributes 0.132 to the overall error. So let's take W7 as an example. So how much do you think we need to adjust W7 such that our error, maybe our error is reduced from 0.44 maybe to 0.34? So that brings us to this graph. So on the x-axis, you can see it says W7, and then on the y-axis, it says error. And then so let's imagine this is our error function. And let's imagine that at this time, our W7 reads, so our W7 sits here. So let's imagine this is 0.45. And then if we trace this up, you can see now, trace it up, it says the error sits at 1.5. Yeah. So the idea is to see how we can adjust W7, nudge adjust W7 such that our error is reduced. So let's imagine that we move our W7 from 0.45 to, let's say, 0.48, or 0.48. So here currently sits at 0.48. And then if we would find the corresponding value for the error, you can see that our error has reduced maybe from 1.5 to 0.5. Yeah, so that's the idea behind this equation here. Now it says that dE over dW7. So how much would E be affected if we change W7 a little bit? So here now, we moved W7 from 0.45 to 0.48, and how much did it impact did it impact E? So our error moved from 1.5 to 0.5. And same thing here too. So if we replace our E by target minus output, so T minus O, so we can also square it such that it's able to get to that global minimum on time. So this is the global minimum. So if you look at this spot here now, at this spot, you can see it says that our dE over dW7, at this point, it is 0. Because at this point now, if you try to move our W a little bit, there won't be any change. So at this point, that's the point we're actually looking for. So at this point, your error is at the minimum. So at this point, maybe it's this might be 0.25. So that is where we are driving at. So we keep moving, we keep moving, we keep moving until we hit this global minimum. And at this point, our error wouldn't, there won't be any updates in our error at this spot. Yeah, so let's carry on now. And then you can say dE over dW7. So we'll replace, remember, our E is also equals to target minus output. So that is T minus O. And then you can see that we've also expanded it here too, using the chain rule. And then here now, so same thing as what you have on the left-hand side. So the output. So it's still dE over dW7. Yeah, so same thing too. And then just take this back. Just like we mentioned earlier too. So we can also replace E with t minus 0, and then we square. And then, so that means dE over the output times, remember, the output, this output means this one. So this is our output. So our output, if you look at this, this equation here now, our output here is what? O3 times W7 plus O4 times W8 plus O5, that's what we have here now, times O5 times W9. And then you pass everything into your sigmoid before you find your output. That's what you have here now. So here, our output is also the sigmoid, all of these over the W7. And then if you do differentiate this with respect to the output, so 2 comes down, and then you differentiate this. You differentiate this, you are left with minus 1, and that's what you have in front. So you can do your differentiation, revise your differentiation, and this would give this one. And so let's imagine that all of this represents S. So, and then if you were to differentiate this, you can also check, if you were to differentiate this, would have S, so all of this now, for short, S into 1 minus S. So if you were to differentiate this with respect to W7, and then you differentiate what you have inside the sigmoid. So if you were to differentiate this with respect to W7, it gives 0.3. So you can also revise your differentiation. So we want to differentiate this with respect to W7, and this would give S. So S stands for all of this, for short, into 1 minus S, all of this. And then you now differentiate whatever you have inside with respect to W7. And that gives O3, and that's what you have here now. So that means that if you would want to adjust, all right, if you would want to adjust, so it gives this now. So if we would like to adjust W7 with respect to E, then we would have to use this equation. Same as if we would also like to adjust W8 such that the error is reduced, we'd also have to use this now. You can see the same thing, but here I can see O4. So if we were to differentiate this, so imagine we had 8 here. If we had to differentiate what you have inside with respect to W8, we're left with is O4. That's why you have it here. And then if we're also doing this with respect to W9, and so imagine we have, instead of 7, we have W9 here. And then if you differentiate whatever you have inside, you are left with O5. Then that's what you have here now. So that means we already have these 3 formula here. So if we want to adjust W7 such that the error is reduced, we'll use this formula. And then if we also want to adjust W8 such that the error is reduced, we use this formula. And lastly, if we would like to adjust W9, adjust such that the error is reduced, we would also use this formula. And we can also put these in a matrix form, you can see. So this and this and this are the same. So instead of having T as target minus output, you can also replace this with E. And then you have our S, which is all of this, the sigmoid and all of that. S into 1 minus S. And then you can see we flip this down. This is a 3, 1, 2, 3, 3 by 1 column. And then we'll flip it here now. You can see now. And then this becomes a 1 by 3 column, and then this is what a 1 this is a 1 by 1 matrix, and then this must align. You can see this must align, and then this gives us output of 1 by 3. So 1 by 3. You can see, and that's the output here now. So this will give us 1 row and 3 columns. That will reflect how much you need to adjust W7, how much you need to adjust W8, and how much you need to adjust W9. So as an example, so imagine this is our one by one matrix, and then this is our 1 by 3. Then if we do the matrix multiplication, you can see as it tells us how much we need to adjust how much we need to adjust W7, how much we need to adjust W8, and then how much you need to adjust W9. I hope this helps. We'll continue in our next video. Thank you very much.